Hello everyone. This video is on section 9.4 titled Solving Equations by Using Quadratic Methods. So in this video I'm going to be going over a version of the Knewton Alta assignment for section 9.4. Please understand that the version you see in this video may or may not be the same version, the same questions, that you see when you do the assignment on your own. But the objectives are the same, the types of questions should be similar, so I'm hoping that watching me do these here help you in some way when you work on it yourself. Alright. So here's the assignment page. Now you will not see the words preview of, you'll just see the title of the assignment. You'll also see a mastery bar, right, telling you how far along you've gotten. Got the objectives. It looks like there are 2 objectives in this particular section, this particular assignment. And then related to the current objective, there should be a question below it. And at the bottom of each question, there will be a feedback button where you can send feedback to Knewton. You will not see the instructor cheat button, right? That's only for instructors. But you will see a more instruction button. Right, if you click on this, you'll be provided with further reading material or videos that will hopefully help you when working on certain questions and certain objectives. Okay, so this first question is on the objective: solve an equation in quadratic form with rational or negative exponents by using substitution. Alright, so what we're going to see here in this objective and in the other objective as well, we're going to be looking at equations that don't look quadratic just yet, but we can make a simple substitution to change them into a quadratic equation. Then we solve that quadratic equation, substitute back, and then solve for the variable that we started with, right? And here we're given variable x. Alright, so let me show what I mean with this example here, and I'll go, and we'll be seeing this in every single question in this particular assignment. Okay, so this equation we're first given is 3 times x to the 2/3 power, or a fraction power, minus 10 times x to the 1/3 power, another fraction power, equals 8. Now what we're going to be seeing throughout this entire assignment here are equations that are quadratic in form. So equations that are quadratic in form, in the form they can take. And what that means, right? Equations that are quadratic in form, these are just equations that can be written in the following form. That can be written as, now I'm going to use the letter u here. A times u squared plus b times u to the first plus c equals 0. Alright, where a, b, and c are just numbers. A is not 0, because if a were 0, it wouldn't be quadratic anymore. And u is any expression I want. U is some expression with a variable in it. Here it's squared, here it's to the first power. Alright. So let me show you that this equation here that I'm first given is one that's quadratic in form, can be expressed this way. Alright, so first I want to get everything on one side, 0 on the other. So we have 3 times x to the 2/3 power minus 10 times x to the 1/3 power. And then I would be subtracting 8, right? Minus 8 equals 0. And then if you remember your properties of exponents, remember the power to a power rule, I can write this first term as 3 times, and then x to the 2/3 power is the same thing as x to the 1/3 power squared. Right, that would be x to the 2/3 power. Then the next term is, minus 10 times, and then you have x to the 1/3 power, and I'm putting it in parentheses for a reason you'll see in a second. And then we have minus 8 equals 0. So do you see how this is in quadratic form? You see how this is in quadratic form? You see I got a number, 3, times some expressions squared, u squared, x to the 1/3 squared, plus another number, negative 10, times that same expression, that u to the first. And see here it's the same expression, x to the 1/3 to the first power. And then plus a constant, right, plus negative 8 equals 0. It has the exact same form as a quadratic equation. So what we're going to be doing, what I'm going to be doing, you don't have to do this, but it makes things easier, I find, for most people, is I'm going to make a substitution for this u, for whatever this expression to the second power and to the first power is. I'm going to make a substitution. And I guess in most of these I'll just call it the letter u. So this x to the 1/3 power, right, that acts like the u over here. So I'm just going to let u replace x to the 1/3 power. So that changes this equation into the following. So instead of 3 times, x to the 1/3 squared, it's 3 times u squared. Minus 10 times, and then instead of x to the 1/3, that's 10 times u. And then minus 8 equals 0. So do you see now I have an equation that is quadratic in u? Right? This is what we're used to from sections 9.3, 9.2 earlier in other Knewton Alta assignments. This is a quadratic equation in the variable u, right, in u. And that means I can solve for u. All right, so what we're going to do is I'm going to make a substitution. Right, and once I recognize that the equation is quadratic in form, I'm going to make a substitution to change it into a quadratic equation in some variable. In this case it's u. In most of these cases I'll just make it u. And then we solve for the substitution variable, solve for u. I'm going to solve for u in this equation here. Now you can use the quadratic formula. You can use completing the square. If the quadratic is factorable, you can solve by factoring. There's lots of things you can do. All right. This one here, I can see is factorable. All right. You'd have to have 3u in one of the factors, u in the other one. And then I'd have to have a minus 4 over here and a positive 2 here, right? This factors the 3u plus 2 times u minus 4. And you can double check by multiplying. You'd have 3u squared. Minus 12u plus 2u would be minus 10u, and then minus 8. And so u is either negative 2/3 or u equals, positive 4. Now you're not done. All right, I'm not done. I made the substitution for u, solved for u, but remember the original variable was x. I want to solve the original equation, which was in terms of x. So now I must, after solving for the substituted variable, now I'm going to substitute back and solve. Right, substitute back and solve for the original variable. So remember what u was. U was x to the 1/3 power. So now these become, x to the 1/3 power equals negative 2/3. And this u equals 4 becomes x to the 1/3 power equals 4. Now if you want to undo, the 1/3 power, remember this is like the cube root, the 1/3 power, just raise both sides to the 3rd power to get x to the 1st, right, to get x to the 1st alone. And negative 2/3 to the 3rd power would be negative 8/27. And then same thing here, x to the 1/3, the cube root of x equals 4. Raise both sides to the 3rd power. You get x equals, 4 to the 3rd is 64. These are values of x that should satisfy the original equation, but don't forget to check them. Check these back in the original equation. Alright, so here's the original equation again. Alright, way back here. It was this. It was 3 times x to the 2/3 minus 10 times x to the 1/3 equals 8. If x were negative 8/27, negative 8/27 to the 2/3 power, take the cube root first, which would be negative 2/3. Squared would be 4/9. And then I'd have 12/9. 12/9 minus, and then 10 times 4. Oh, not 4. The 12/9 minus 10 times, and then put in, the cube root of this is negative 2/3 again. So 12/9 plus 10 times negative 2, so it's 20/3, which would be 60/9, be 72/9, which is 8. Alright, sorry about all that confusion there, but this does work. And the same thing goes for 64. We'd have 3 times 16, right? 64 to the 2/3 power would be 16, would be 48. Minus 10 times 4 would be 40. 48 minus 40 is 8. Both of these work out. So negative 8/27 and positive 64 are the solutions of this equation. And we're asked to, when we enter the solutions, separate them by commas, right? Negative 8/27, comma 64. And after every question, there should be an answer explanation, whether you got it right or wrong. I would highly recommend reading that either way. If you got it correct, read through it just to make sure you got it right for the right reasons, right, and that you didn't make a, just get lucky. Or maybe they went through it in an alternate way that you like better, and you might want to try for future questions that are similar. Now, if you got it wrong, definitely read through the answer explanations, because you want to figure out where you went wrong, right, why you were wrong, and hopefully you can learn from your mistakes. Alright, so next question. Now we're in the other objective, solve an equation in quadratic form by using substitution. So it's the same thing. It really is. Alright, it's the same concept. Alright, so here, solve this equation, enter all solutions separated by a comma. Do not include x equals in your answer. Right? So I'm going to write this equation out and show you, what substitution will I make to change it into a quadratic equation. Then I'll solve the quadratic equation and then substitute back and solve for the original variable. Alright, so here's the equation I'm given. Now it's not quadratic yet, but it's, everything on one side, 0 on the other. And you may notice in all these, like in the first example, you had a power of 2/3 and then 1/3 and then a constant. So the first power was twice the second power, and then you had a constant. Same thing's happening here. The first power is 4, second power on the variable is 2, which is double that, and then a constant. So that gives you a good indication that this is a quadratic, or this is an equation that is quadratic in form. And watch this, just using properties of exponents, 36x to the fourth. X to the fourth is x squared, right? Minus, and then 83 times, and then here we have x squared to the first. And then plus 35 equals 0. So you see how this is quadratic in form. I'll make a substitution. I'm just going to write sub. These x squareds, right, the expression being squared here into the first power here, I'm just going to replace that with u again. So now this equation becomes, 36 times u squared, right, x squared is u squared, minus 83 times, u to the first, or just u, then plus 35 equals 0, right? So I've changed it now into a quadratic equation in u. And now I'm going to solve this, right? We solve for u. Alright, this time I'm just going to use the quadratic formula. Alright, this is for the quadratic formula. So we get u equals, the opposite of the linear coefficient, which would be positive 83, plus or minus the square root of, negative 83 squared minus 4 times a times c, so 4 times the quadratic coefficient, 36, times 35, and then all of this divided by 2 times 36. Alright, and this might actually end up being something nice. We'll see. In fact, I'm going to pull up a calculator here and we'll look at it, what these values are. Okay, so you see a calculator just pop up on the screen there. I shifted over the values here. I'm just going to enter the discriminant right now. We got 83 squared. Negative 83 squared is the same thing. So 83 squared, negative 83 squared will still be positive. Minus, 4 times 36 times 35. And see what we get there. That's 1849, and I don't think that might be a perfect square. Let's see. Yeah, 43. So this is actually factorable. Remember, if the b squared minus 4ac is a perfect square, that means your polynomial was factorable, your quadratic was factorable. Okay, so getting rid of the calculator here, going back. This square root here, this square root of the discriminant, that's just 43. So this is 83 plus or minus 43 all over, 2 times 36 is 72. And we're getting two solutions here, right? U equals 83 plus 4, we got two of these. Right? 83 plus 43 be 126 over 72, which I can reduce. 9 goes into both of these evenly, I'm pretty sure. Yeah, this would be 9 times 14. So 18 times 7. And this is 18 times 4. That's 7/4. Alright, 7/4. All right, and then the other one is 83 minus 43. That'd be 40 over 72. This is 4 times. That's 8 times 5. That's 8 times 9. All right. 8 times 5. 8 times 9. The 8's cancel. This is 5 ninths. Right, so or u equals 5 ninths. Okay. So I took this equation here and solved for u. But remember, the original equation was in x. I want to find solutions with x, right? X equals. So now we sub back. Right, now we sub back. Remember, u was x squared. So these equations here become, x squared equals 7/4, or x squared equals 5 ninths. Right, and then I solve these. Now these are quadratic, but these are easy to do with the square root property. Right, if x squared equals 7/4, that means x equals, positive or negative square root of 7 divided by 2. Right, the square root of 7/4 would be the square root of 7 divided by the square root of 4, which is 2. Or, and then the solutions coming out of here, x equals positive or negative square root of 5 divided by 3, right, the square root of 9. Don't forget to check them, but I'm telling you right now, these should all work. So again, this is 4 solutions. Positive square root of 7 divided by 2, negative square root of 7 divided by 2, positive square root of 5 divided by 3, and negative square root of 5 divided by 3. All right, so that is what I'm going to be entering back in the assignment. So I enter all solutions separated by a comma. Right? So one is positive square root of 7, get out of there, divided by 2, comma, then negative square root of 7 divided by 2, comma, square root of 5 divided by 3, comma, and then negative square root of 5 divided by 3. Right, and that's all 4 solutions that I had written up on the previous page. And it's taking a little bit here to check. Great. All right, and then once again, please, read through your answer explanations. All right, next question. But yeah, I'm doing the same thing every time though. All the questions, no matter what the objective is here, is just going to be make some sort of substitution, solve the resulting quadratic equation, and then sub back and solve for the original variable. All right, so once again, I'll write this out and we'll talk about it. Okay, so this question is pretty similar to the last one I did, where you see that everything's on one side, 0 on the other, and the power on the first term is twice the power on the second term, and then you got a constant, so it's very much in quadratic form. And I'll show you how it is. Right, again, we have 15 times, and the x to the 4th, that's x squared to the second, minus 11, then x squared is just simply x squared to the first, plus 2, plus the constant 2 equals 0. Then I'll make the substitution. I'll replace x squared with u. Right, all these x squareds here I'm going to replace with u. So after the substitution, this equation looks like this: 15 times u squared minus 11 times u plus 2 equals 0. And then I solve for u. Right, or solve for what you don't have to use the u. I'm using u each time, but you can use any letter you want. All right, as long as it's not the original letter again. So now I'm solving for u. All right. Now I think this one's factorable. I mean, the last one was factorable as well. I just the numbers are pretty big and I didn't see it. Now again, you can use the quadratic formula to solve for u, completing the square. If it's factorable, you can do some factoring too. This one is factorable. This one is factorable. I can see it. Alright, so I would need a 5u and a 3u, and then minus 1 here, minus 2 there. Right. There's your 15u squared, minus 5u, minus 6u for the minus 11u, and then plus 2. Alright, so u is either 2/5 or 1/3. Alright, 2/5 or 1/3. But then we sub back. Alright, and solve for the original variable. So that means, remember what u was? U was x squared. So we have x squared equals 2/5. X squared equals 1/3, and then I can solve both of these pretty easily with the square root property, right? If x squared is 2/5, then x must be positive or negative, square root of 2/5, which would be the square root of 10/5. After rationalizing, right, I have the square root of 2 divided by the square root of 5, and I multiply the top and bottom by the square root of 5. Right? I'm rationalizing the denominator. And then same thing over here, x equals, the square root of 1/3, which is just the square root of 3 divided by 3 after rationalizing. Right, multiply the square root of 1, square root of 3, multiply the top and bottom by the square root of 3. And you get these, plus or minus, of course, right? Square root property. Both of those squared would be 1/3. And again, I get 4 solutions here. Positive square root of 10 divided by 5, negative square root of 10 divided by 5, positive square root of 3 divided by 3, and negative square root of 3 divided by 3. And I'm entering all of those. And square root of 10 divided by 5, comma, negative square root of 10 divided by 5, comma, and square root of 3 divided by 3, comma, negative square root of 3 divided by 3. And those 4 solutions there. Wonderful. All right. Again, please read through your other the answer explanations whenever they pop up. All right, so we're still in. All right, now we're back to the other objective where powers will be rational or negative, and it's the same concept. All right, same concept. I'm going to be doing some sort of replacement, some sort of substitution to change my current equation into some quadratic equation. I solve that quadratic equation and then substitute back and solve for the original variable. Alright, so here we're given x to the 2/3 minus 3 times x to the 1/3 equals 28. And I'll show you how this is in quadratic form. X to the 2/3 is x to the 1/3 squared. Minus and then 3 times, and then x to the 1/3 is x to the 1/3 to the first. And then I would subtract 28, get everything on one side, 0 on the other. And now I make the substitution. These x to the 1/3 powers I'm going to replace with u. Alright, so u replaces x to the 1/3. That changes this equation to the following. Be u squared minus 3u minus 28 equals 0. Alright, then I solve this for u and sub back. So this actually, again, you can use the quadratic formula, completing the square, those are totally fine. It's just if it's factorable, that might be easier as well. Like this one's easily factorable. This factors to u minus 7, pardon me, I had to clear my throat there, times u plus 4. Alright, this would be u squared minus 3u minus 28 factored. Alright, so I'm getting possible solutions of u equals 7 or u equals -4. And then we sub back. Alright, then we sub back. I solve for u, but I want to solve for x. The original equation had x. And what did u represent? U represents x to the 1/3. So this is x to the 1/3 equals 7. Or, x to the 1/3 equals -4. And then to get x alone, to solve for x, I'd raise both sides to the 3rd power. Alright, this is the cube root of x. I raise both sides to the 3rd power. X equals 7 to the 3rd power is 343. And then here, -4 to the 3rd power would be -64. And there's your solutions. And don't forget to check them. Alright, don't forget to check them back in the original equation. And they both should work. Yeah, they do. Alright, I'm just kind of doing it mentally here. Alright, so back here, the two solutions. 343 comma and -64. Wonderful. Right, yeah, so again, you've been seeing every single question is pretty similar. You're making a substitution, solving the resulting quadratic equation, and then subbing back and solving for the original variable and checking your solutions, of course. Right. So another one with the 4th power. So these are pretty similar to a couple ones I've done earlier. Okay, so once again I'll write this out as to show you that it's in quadratic form. Alright, x to the 4th is just x squared minus 67 times x squared is simply x squared to the 1st plus 72, and then we have equals 0. Definitely quadratic in form. I'm going to make the following substitution, right? I'm going to replace these x squareds with u. So after making the substitution, this equation becomes 15 times u squared minus 67 times u plus 72 equals 0. Alright, and then I try solving this quadratic equation for u. Alright, so you know what I'm going to do? The numbers are larger here. I mean, you could try factoring and whatnot. It might be factorable, but because the numbers are so big, I'm just going to go to a calculator here. We got u equals, and then using the quadratic formula, be the opposite of b, which would be positive 67, plus or minus the square root of b squared, right, negative 67 squared, which you could also just write 67 squared. It'll be the same value. Minus 4 times a times c, right, 4 times 15 times 72, all in the square root there. And then all of that divided by 2 times a, 2 times 15. Alright, let me go to pull a calculator up once again. And first I'll enter the discriminant, the b squared minus 4ac. So you have 67 squared minus 4 times 15 times 72. That's 13. Right, the square root of this is 13. Okay. And then we go, 67 plus 13, right, because this whole thing here is 13. So 67 plus 13 would be 80 divided by 30, 8. Alright, so the denominator is 30. Alright. So I have 80 30ths, or 8 thirds. So one solution is u equals 8 thirds. The other one is 67 minus 13. Should be 52 over 30. Right. Not 52. Right. 67 minus 13 be 54. Right. 54 divided by 30 is 1.8, so 18 tenths or 9 fifths. Right. So there's the two solutions, 8 thirds and 9 fifths to that quadratic equation. Alright, to the quadratic equation. But I don't want solutions to this quadratic. I want to go back and solve for x. So now using what I sub for, this means that x squared, u is represented by x squared. Right? X squared equals 8 thirds, or x squared equals 9 fifths. And then from the square root property, you get x equals plus or minus the square root of 8 thirds, which when you totally simplify your radicals and rationalize, and I leave it to you to figure out how this was done, this would be 2 times the square root of 6 over 3. Alright, because the square root of 8 is 2 times the square root of 2, and then you multiply the top and bottom by the square root of 3, and then you rationalize the denominator. And then from here, when x squared is 9 fifths, that'd be x equals plus or minus the square root of 9 fifths, or rationalizing and simplifying, you have plus or minus 3 times the square root of 5 over 5. There are the solutions of this equation. So 2 times the square root of 6 divided by 3, negative 2 times the square root of 6 divided by 3, 3 times the square root of 5 divided by 5, and negative 3 times the square root of 5 divided by 5. And I will enter all 4 of those back in the assignment. So 2 square root of 6 divided by 3, comma, negative 2 square root of 6 divided by 3, comma, 3 square root of 5 divided by 5, comma, negative 3 square root of 5 divided by 5. Right, and those should be good. Wonderful. Yeah, same steps every time. Right? All these equations in this section, in this assignment, I am following the same procedure. Alright, so next question, same procedure. Right? Another one with a 4th power and a 2nd power. Alright, so very similar. So let's write this out and come back to it. Alright, so this is very similar to the previous ones. I'm going to just do the substitution right now. Let u be x squared. And then we have 72 times u squared, right? Because x squared squared is x to the 4th, right? U squared would be just x to the 4th. So that's 72u squared minus 74u plus 14 equals 0. Right. And just to make the numbers a little bit smaller here, I'm noticing that all the coefficients are even, so what I'm going to do is divide by 2 on both sides, just to make the numbers a little bit smaller. So that'll be 36u squared minus 37u, and then plus 7. Equals 0. Okay. And then I'm going to solve this quadratic equation here for u and then substitute back and solve for x. Okay, now let me see. Let me see if this is factorable. I'm going to do some guessing and checking here. I'd have to have a -1 and a -7 because I need to add up to a negative middle term and have a positive 7 in the last term. Now 36, I could break up to 36 and u, but that won't cut it. I can break up to 4 and 9. Alright, so that would be, should be 4u here and 9u here, right? That'll give me 36u squared minus 28u minus 9u for the minus 37u and positive 7. Great. Alright, so the solutions to the quadratic here are u equals 1/4 or u equals 7/9. But then don't forget we're subbing back, right? I don't want to solve for u, I want to solve for x. So subbing back, u was x squared, right? So we have x squared equals 1/4 or x squared equals 7/9. And then using that square root property and also rationalizing denominators and stuff, you know, when x squared equals 1/4, x is going to be positive or negative 1/2. Right? And when x squared equals 7/9, x is going to be positive or negative square root of 7 divided by 3, right? The square root of 9 is 3. And here are the 4 solutions to that equation. 1/2, negative 1/2, square root of 7 divided by 3, and negative square root of 7 divided by 3. And those are what I'm entering with commas between them. Right? 1/2, negative 1/2. Oops, I forgot the comma. Comma, negative 1/2, comma, and square root of 7 divided by 3, comma, negative square root of 7. Nope, nope, nope. Get out of there. And then divided by 3 outside. Right. There we go. Great. Alright, so it looks like that objective is done. But still I'm doing the same procedure in the other objective as well, right? Making a substitution. I've said this a bunch of times now, right? Make a substitution, turn it into a quadratic equation, solve the quadratic, then sub back and solve for the original variable. Okay. So these last questions should involve, you know, fraction powers or negative powers. Probably just the fraction powers again, so it's very similar to some ones we've seen earlier. Alright, so we've already seen examples like this with the x to the 2/3, x to the 1/3 power. If I substitute u equals x to the 1/3, right, then that means u squared would be x to the 2/3. Right. So this will be 6u squared minus u, and then I would subtract 12 to get everything on one side, 0 on the other, get it in standard form. Now once again, you can solve this quadratic here for u, solve it with the quadratic formula with completing the square. Again, I can see how this one will factor. Alright. This one's going to factor, got 3u, 2u, and I would need minus 3 here, plus 4 there. Right, that'll give me the 6u squared, minus 9u plus 8u for minus 1u, and then minus 12. Great. Alright, now the solutions to this. One is u equals negative 4/3. The other would be 3/2, positive 3/2. And then we sub back. Now remember, u was x to the 1/3 power. So we have x to the 1/3 power equals negative 4/3, or x to the 1/3 power equals 3/2. And then to solve for x in both of these, I'm going to cube both sides, right? Raise both sides to the 3rd power. So from this first part here, we have x equals -4/3 to the 3rd power would be -64/27. And then raising both sides of this equation to the 3rd power, give me 27/8. X equals 27/8. And there's your two solutions to the equation we were given. -64/27 and 27/8. Again, separated by commas. -64/27, comma 27/8. Great. Alright, so I should have just one more of the like these, like this one. And again, I'll write it out and come back on a piece of paper. Alright, now this one has just a single fraction power, but you know, the power here, x to the first is double x to the half, right? The first power, 1 is double half, right? So if you see that happening, as we've seen throughout all these questions, you have something that's quadratic in form. Right? So you should be able to make a substitution and change it into a quadratic equation. Alright, so I hope you can see the substitution here I would make would be let u be x to the half, right? Because then u squared would just be x. Right? X to the half squared would be x to the first. So then making those substitutions, you know, 2 times x would be 2 times u squared minus, you know, 7 times x to the half would be 7 times u. And then I'd subtract 15, you know, to get everything to one side, 0 on the other, and get a quadratic equation in standard form. Alright, and then I'm going to solve this. Now again, you can use the quadratic formula, completing the square, but this is another one that is nice and easily factorable. Alright, this would factor to, you know, you'd have 2u in one factor, u in the other. I would need -5 here and a +3 here. Right, that gives me the 2u squared minus 10u plus 3u for -7u and then -15. Alright, so the solutions here are u equals -3/2 or u equals 5. Okay. Then replace u with, you know, x to the half. So we have x to the half equals -3/2 or x to the half equals 5. Now this is a little trickier. You know, earlier questions we had x to the 1/3 power, which was the cube root, odd root. Here we have x to the half power. Remember, this is the same thing as the square root of x equals -3/2. The square root of x equals 5. And you might recall that the square root that symbol means the positive square root. So the square root of x being negative can't happen. Now let's say you didn't see that. Right? This is one where you really have to check your solutions. You know, to undo this, I'd square both sides, raise both sides to the 2nd power. Same thing for this equation, right? Square both sides to get x to the first. So we get x equals, you know, 9/4 from there. Here we get x equals 25. Right? But because of the even root, I'm telling you, right? Odd roots are fine. because of the even roots, you should definitely check your solutions for sure. I mean, you should always check your solutions, but definitely check your solutions when there's an even root involved. Alright, so let's test it out. So here I'm going to check. Let's say x equals 9/4. Alright, so we had 2 times 9/4 minus 7 times 9/4 to the half equals 15. Alright, let's see if that's true. This would be 9/2 minus 7 times, and then 9/4 to the half power. This, the square root of 9/4 would be 3/2. Is that equal to 15? Well, that's 9/2 minus 21/2 equals 15. This is negative 12/2, or negative 6. Negative 6 equals 15. No, that does not work. So we have an extraneous solution. Alright, which is what I was telling you a second ago, right? Because of this even root being a negative number, that's not happening. Alright. So let me cross that a little more darker here. That is not a solution, 9/4. But 25, right, let's check 25. 2 times 25 minus 7 times, 25 to the half. Is that equal to 15? Well, this is 50 minus 35. Is that equal to 15? Absolutely. So 25 works, but 9/4 is extraneous. All right, so just be careful with even roots. Even roots. All right, as you've always had to be careful with even roots. All right, so going back to the assignment, right, the only one I'm entering, the only one that's any good, is 25, right? Not 9/4. Well done. And again, they're going to point that out in the answer explanation, I'm sure. All right, see, they point out that, hey, 9/4 doesn't actually work. All right, so it's extraneous, and then the only one that works is 25. So just be careful again when you have fraction powers and the denominator of that fraction is even. You got to be a little more careful, a little more wary of things. But you should be checking your solutions anyway, right? You should do that's just something you should do for any equation anyway. All right, so that should be it for this version of this assignment. As I said at the top of the video, right, the questions I see here in this video are not necessarily going to be the same questions you see when you work on it at home on your own. But the objectives were the same. The types of questions should be similar. So I'm hoping that watching me go through these 8 questions here help you out when you're working on it yourself. And thank you very much for watching.